Jacob Ruytenbeek, CEO and founder of SailPlan. Welcome to the Epic Human Podcast. Thanks for being here.
Thank you for having me. That's exciting.
It's a joy to do this. We've been talking about potentially doing this for, I want to say like over a year. So I'm excited that we're finally making it happen.
Me too.
Yeah.
Me too.
So why don't we start by just, a conversation around like what SailPlan is, and sort of how you founded the company.
Sure. There's a lot to unpack there. So let's start with SailPlan. The SailPlan is a real-time, high-resolution monitoring system for ships that today is really focused on the combustion process and emissions. And what that means is we're able to actually directly sense the emissions coming from ship's exhaust, helping them voyage more efficiently, understand what's happening in the engines, identify ways to save fuel that was not, previously possible. It's really exciting technology that's been adopted now by dozens of ships. So in a nutshell, that's what SailPlan is. And there's a lot to unpack there and how SailPlan works and really where it can go. But I started it because my dad was a marine electrician. I grew up in South Florida, and I had a love of the ocean. So from the time I was a little child, one of my earliest memories was going to the docks with my father. I was like maybe 5 or 6 years old. He had this big black conversion van with filled with tools, and he was building yachts for Broward Marine. I remember going there one day and having my little lunchbox, sitting on the dock, looking at the yachts he was building, and I fell in love. Like, Dad, you have the best job in the world. He's like, must have looked at me like, okay, kid. But nonetheless, I was hooked. I remember standing there on the bridge of one of the yachts as a young kid, and just like, I want to do something with this world. Fast forward. When I was a little older, I became a scuba diver. When there was good surf in Florida, which there unfortunately isn't that great of a surf community or surf scene, the community's great. I'd be surfing out there. I'd be snorkeling, swimming, like many other Florida kids. And I started to pay close attention to the environmental issues. I remember one time I was on a reef cleanup, and I found a refrigerator on a reef. Yeah. And so I was like, well, how are we going to get that up? But like the bigger question was like, I was like 10 years old, 11 years old. I was thinking, well, how does this get here? Right. Like, how do you get a refrigerator on a reef? And then you start looking at the other issues, right? The decimated fish population, the bleaching of the corals. Today, the issue of plastics is ever present. A walk on the beach in South Florida, and we always bring a small bag with us. And you can't walk 100 yards without filling up the bag with trash. And that's just a horrible state of the environment. If that's what's on the beach, what else is beyond what we can't see? So it really, for me, it was a call to do something with my life. And there was no better place to start than helping ships voyage more efficiently. So we're conserving energy and being better stewards of the environment.
Wow. I remember when we were on the boat together a few weeks ago, you were picking up plastic and leaning over the ship and picking up plastic floating in the water.
Did I do that?
You did, yeah.
I actually, it's
you probably don't even notice you do it.
I don't notice. One time, my son started yelling at me because we're going down the intercoastal waterway, and I must have seen. I saw like a toilet paper packaging. Like, it was just this huge piece of plastic sitting there. And so I just naturally left the helm, walked through the back, pulled out a gaff, and walked to the side. And my son's screaming like, "Dad, you let the wheel go. What's going on?" And he's like, "What are you doing?" And for me, it's just like, well, you got to get it out.
Yeah.
Small.
Well, this is a little bit different than any podcast I've done before, in that we have some video that we're going to show that we're going to watch ourselves and show to the audience, and it's going to help kind of explain SailPlan, the product, and how it works. So why don't we give it a shot here?
Let's do it.
And thank you to the video production company that helped put this together. So starting with some drone footage of Fort Lauderdale, and
it's a great place to put our office. I love this area that we're watching right now. I like it. I see in the video it's actually a little stuttery. I thought that was just on my iPhone.
No, and it was funny is when they were doing the video drone footage, they lost the drone for a little while. So I'm glad they were able to recover it and get some of the video. But this is explain this. What waterway is this that we're showing?
This is the new river in Fort Lauderdale. It's actually one of the natural rivers that has been there for millennia. And a lot of the original inhabitants of South Florida lived along the banks of this river, which is kind of cool because there's so much man-made construction there that this is one of the natural parts of it. And where we're pulling up the vessel right here, the SailPlan test vessel, is actually right in front of our office, which was exciting. So
there you are showing up, and why don't you tell us a little bit about the test vessel?
So the test vessel, her name's Maine Course. She has a long storied history up in Maine where we were able to find her. She's a 35-foot Maine lobster boat that was really built for family purposes. A VC actually owned her and used her every 2 weeks a year for going around the islands in Maine and cruising. And then the rest of the year, for the past 20 years, she's sat on the hard. And so she's in incredible condition for a 20-something-year-old boat, has less than 2,000 hours. And we were able to pick her up. She, believe it or not, she may look different, but under the hood, she's very similar to a large ship that we might actually put SailPlan on. So she's a great R&D platform for SailPlan, where we can deploy our technology on her. We can test and iterate with a live platform that's actually on the water, that's under rather controlled circumstances. So she does research and development where we test new sensors, test new hardware. It's great for us to do that. It's also great for customer experience. Investors can come out on the boat. Customers come out on the boat. We're able to see the technology firsthand. And I think the other thing about Maine Course is you get a sense of the actual experience of SailPlan and what it can do, much less on a smaller footprint. But you can go see how vessels interact with one another, right? It's not just a boat on the water. There's hundreds of other boats near you, large and small, moving at different speeds and different rates. You're in an ecosystem. And I think that's one of the reasons that it's important to bring people out on her.
And we're looking at a few sensors kind of on the top of the boat, and then some instruments inside. Can you give just some context as to what we're looking at and what kind of sensor packages you have here?
Yeah, so SailPlan on board the Maine Course is almost one-to-one with the big ship. So we'll start from the bottom and go up. We pull in high-resolution data around the fuel system, the engine performance, and the actual measured emissions. So unpacking that, the fuel system, we're monitoring fuel flow at a millisecond level, right? So we understand the minute changes in fuel flow aboard the vessel, just like we would on larger ships. Then we're pairing that fuel flow data with engine data. So she has a simple diesel engine, but nonetheless, we're pulling in torque and RPMs from that engine. So we actually have a shaft power meter on there where we understand the torque coming off the shaft. We have an RPM counter, so we understand really how much horsepower or kilowatts or power energy is coming out of there. And then finally, you get to look at the emissions coming out of the Maine Course. And that gives you a high resolution understanding of actual direct measurements in the fuel system. So you're seeing what's going into the engine, what's coming out of the engine and what's happening in there, because you're going to naturally ask questions of like, how well, like, how do I save fuel? Well, but there's a question. You got two options on saving fuel on ships. You can burn less fuel, or you can also burn the fuel that you are combusting more efficiently, right? And what SailPlan's really designed to do is answer both of those. Identify strategies for you to burn less fuel, but then find ways that you're improving your combustion efficiency. Fuel is simply stored energy, right? And so how do we convert the maximum amount of that stored energy in a liquid form into a mechanical energy at the output? And by measuring the exhaust gas concentrations, we can really start to understand that in very high resolution. And then we, aboard the main course today, as you'll be able to see in some of these images, we're actually alerting the operators through the UI installed on the ship onto how to interact with those emissions and the fuel consumption information.
Right, and the analogy I use for some people is to think about their own car, right? In terms of, if you get a rating on like what your engine performance is, 28 miles per gallon, right? That's a rating for highway driving at a very specific speed. And they really design engines around that. So the way I describe what you guys do sometimes is you're taking advantage of the kind of natural efficiencies that is designed into this equipment and allowing the operators of these vessels to operate more efficiently in that way.
There are. That's a good way of looking at SailPlan. I think one of the things that most people underappreciate about ships is just how complex they are. When you look at a car, you have a single engine. Most of the ships out in the bay out here do not have single engines. They may have one primary engine that's used to propel the ship, but sometimes two, sometimes four. They have auxiliary generators that can be configured in many different ways. So it's not like you're just optimizing a single engine. You have to consider how you generate power to provide sufficient power for all the different loads and consumers aboard the ship, right? You got to run air conditioning. You got to run pumps. You have to operate cranes. You have to drive the ship and generate power for propulsion. You may have to generate water, which is an important thing for ships, and they generate a lot of water on board. All this eats up power. The big question is, well, are you doing it efficiently? How many engines are you using to generate that power? If you're, what we look at is we say, if you're just measuring the inputs, then you're going to have a really hard time understanding the outputs. It's better to start with the outputs as well, right? Measure your outputs, measure out your inputs, and then measure where the balance is on that. We've had, going back to ships, we've had a lot of success there because historically there's no HMI, there's no user interface on a ship to tell you how to do these things. You might spend $100 million on a ship, but you still have no idea how much fuel you're consuming moment to moment. Most people don't believe it, but ships often, you'll dip a stick into the fuel tank, right, to take the levels. Or you'll do a sounding of the tank, but oftentimes there's no fuel gauge even on board. So we're really starting from a very basic level with a very complex system, and we're providing additional insights into how to operate more efficiently.
And tell us about what you're describing here in the video here on these screens, because I remember it'd be good to have additional context there for the audience.
Yeah, so aboard main course, we have pretty much a one-to-one interface with the large ships, just obviously scaled down for a single engine operation here. And what we're talking about here is how we're looking at our fuel consumption, we're looking at our speed, and doing some basic speed optimization. Here we're actually pulling up data from other ships and showing you just how they compare to each other. So this is actually some data from Port Fourchon, Louisiana, where we have ships operating right now. We also have terrestrial ground monitoring stations pulling in air pollution to help make air pollution actionable for ports. But that's an important point because, as you can see on the screen now, we're cruising by a cruise ship in Port Everglades, Florida, right? And the question is, if the port had to decarbonize, is it the ships that are the main generators of emissions in the port? Is it the cranes? Is it the passenger traffic? Is it the car traffic? Is it the trucks coming in? There's a lot of contributors to the emission, and ships are just one of them, but it really is that ecosystem. So by providing high resolution data to the ships themselves, they get a solid independent understanding of how they're generating power, what emissions they're actually putting out into the atmosphere. And I'll dig into that for a minute, because to date, the way that the process is done is they use fuel-based emissions factors. Do you know about those? Are you familiar with factors?
Explain that.
So fuel-based emissions factors aboard a ship, you measure your fuel consumption to the best of you can. I mean, if you're dropping a stick in the tank or a string, a plumb line in the tank, and pulling it up, it's already going to be inaccurate. But then you use an emissions factor. You multiply your units of fuel consumed. You know, I burned 10 tons today or 20 tons today by this emissions factor, which is a single number that is theoretically designed to show how the carbon content stored in a unit of fuel, in a ton of fuel, converts to CO2. And for instance, it's like 3.1 is the standard emissions factor. And what that says is that it's an upper bound calculation. It assumes that all the potential carbon, potential energy was combusted perfectly into a very special ratio of CO2 and nitrous oxides and everything else that comes out of there. But the truth is that's an upper bound calculation. And what we find is that by directly measuring what's coming out of the exhaust, we're actually able to get a much more precise understanding. And as a result, precise is actually lower in almost every case, which is a win-win, right? We want to be more precise. We want shippers to be more precise. And as a result, using this technology helps them lower their reportable CO2 by about 5.5%. So,
wow. I also wanted to touch on something we discussed when we were out on the water in terms of the signals you can pick up when you're out on the water of other ships and like what they're already reporting and signaling out to the world. And maybe you could just comment on that piece.
All ships share a signal called AIS, the Automated Identification System. And it's a lot like ADS-B for airplanes, for anybody listening who might know anything about the aviation world. It's a proactive system where the ship constantly sends out a broadcast signal to other ships nearby. And it says, hey, I'm here. Here's my position. Here's how fast I'm traveling. Here's the direction I'm traveling. But it also gives some rich data, right, about that actually is revealing. It talks about typically the draft of the ship, like how deep does it sit in the water, how it actually can be used for the name of the ship, right, and what it's carrying. And through that, we're actually sucking up all that broadcast data from every single ship equipped with SailPlan, which not only gives us information about SailPlan, but it gives you the context in which that ship's operating. Because if you look at the ecosystem approach, there's things inside your control, and then there's externalities, right? Well, there's a lot of ship traffic, so you're going to have to slow down. You're going to have to speed up to avoid that. There's also weather information that might be, the Coast Guard's experimenting with adapting AIS for sharing weather information in real time. And so it's a rich data source that's publicly available, but really actually hard to access because it's locked in the 25 nautical miles around a ship that we can see. But our ships actually, suck in that information through SailPlan and put it back onto the dashboard for operators. We're also using that for data mining purposes.
Got it. And I'm glad you brought up congestion and ship traffic and weather, because I think sometimes, when people think about, operating engines more efficiently, they think of like, you just kind of set it to this, right? But in reality, there's all these kind of external variables that determine how you want to operate a vessel. And so can you just expand on that? Like just to double click on the complexity of, and how your system kind of dynamically adjusts to that.
Yeah, I'll give you an example of one of the operators that we're working with. That they have a vessel that runs, 4 main engines, and I think has 3 auxiliary generators on top of that. So this vessel is about 450 feet long. It traditionally operates in the Gulf of Mexico, And it's pretty modern as well. It has some of the most modern engines we've ever seen on board. When we got on board, I remember the superintendent of the vessel saying, like, there's nothing to optimize here. We got it covered. I was like, okay, cool. And in some ways, I remember seeing it was also our first vessel. I was like, oh man, this thing's sophisticated. I don't know if there's a lot left to optimize. When you start looking at the way they operate the vessel, though, operational capabilities, these engines are top of the line. Like, they have everything they can do in an automated fashion to get them running at their optimum temperature, but there's only so much you can control. Then there's the human factors component. So with 4 engines and 3 generators, there's a lot to figure out on which engine should I be running. Which engines out of the 4 run most efficiently? The assumption is that they run exactly the same, but our data actually shows that they're wildly different. And that's because the operator really likes to operate on engine 2. Engine 2 has the most number of hours, like 4 times the number of hours on it. So it's really an old engine compared to like engine 1. And engine 3 is somewhere halfway in between there. And when you look at the emissions that come out of these engines, they're all different. Every single one of them is different. And you can look that they actually, as the engine goes through its maintenance cycles, right? As it has problems over time, the engines degrade, right? They and especially engines that are operated at suboptimal ranges, like really low loads. Like, imagine idling your car, and instead of ever taking it on the highway, you just let it sit there idling all day, 24/7 until you get it in the morning, and then you drive to work for 5 minutes. Right? That engine's tearing itself apart. It's actually too cold. So the seals don't fit properly. You have blow by. You have water and water vapors getting into your oils. It's just a horrible place for those engines to run. Now multiply that across 4, and these engines are on all day, just sitting there at very low loads. So that's one of the reasons we see this happen. Multiplied by the excess hours there that's put on some of the engines, and you end up with a different result. Each engine operates very differently in terms of its efficiency, its ability to convert that energy from the diesel to mechanical energy and out the back. So that's the first big insight, is which engine should I even be operating on, right? That's not something that the crew instinctively knows. They just go off of gut feeling and instinct. But then you can go look a level deeper. If I have to make 10 knots out to my destination to get there on time, what's the optimal combination of engines that I need online in order to get there on time? We're not trying to optimize around speed. We're looking at pure mathematical combustion efficiency. Should you do it with 3 engines? Like, if I can make 10 knots with 3 engines, why do I need 4? If I can make it with 1 engine, why do I need 2 or 3 online? And there's some good reasons to maybe have that. Safety. Maybe you have an engine problem. You need a backup online. But if you provide the cost of that operation in terms of your carbon output and your carbon emissions back to the crew and the fuel consumption, then you have other layers to pull back. Should I operate those 2 engines? If I have to have 1 on standby, should I both operate them at like 50% load, like sort of idling my car? Or should I rev one up as high as it go to like 70, 80% load and put a lot of pressure and heat in there and then back the other one off to 10%? What's the optimal strategy there? What SailPlan helps them do is see the actual effect of that in very real detail, and through a series of alarms and insights, recommend different strategies to the operators. In fact, what we found is by taking some of these engines offline, the ships, I'll start here. The ships were actually generating a lot more power than they needed in many cases. And when you dove into it, it's just because that's the way they've always done it, right? Well, we always have 2 engines online, plus some backup generators. Why? Well, because. And no one's ever asked. So now that you start getting the data, you can say, well, the cost of 2 engines online versus 1, when you only need 1, it can save you 50% of fuel. And like, here's the data. Now, interestingly enough, since you're burning that fuel more efficiently by dropping down to 1 engine, you get about a 50% fuel reduction in this case. The case study we did, we only get about a 27% CO2 reduction. 37% nitrous oxide reduction. And that's because your fuel is burning much more effectively, right? You're converting more of the potential energy to power. instead of converting it to things like unburnt hydrocarbons, which are really nasty. We measure all of that, right? We're measuring CO2, we're measuring sulfur oxides, nitrous oxides, unburnt hydrocarbons, water content in the engines, particulate matter concentrations, and we have up to 36 different gases beyond that we can measure. So we really are a breathalyzer for performance and understanding for the crews.
This is the part to me that's so fascinating and I think a little bit counterintuitive, that you rev the engine harder, it burns less fuel and emissions come down. It's like a clear win-win. Let me ask you this. The fuel reduction is like a clear ROI, no-brainer for the customer. What have you found in terms of, how much people actually care about the emissions reduction as well?
Emissions reduction, when we started the company, was probably a top 3 care about for our ship operators. And I was excited because I was like, for the first time in history, people care about emissions. Today, it is the singular issue facing these companies. It is typically managed directly by the CEO or CFO. It is a top issue. In some cases, the emissions footprint for shipping is existential. It's now an existential crisis for many ship operators. Things like the carbon intensity indicator, which came into force on January 1st this year, is an example of that. It gives a letter grade to every ship in the world. And realistically, they're going to have to slow down. The majority of ships in the world are going to have to slow down by about 5% next year. And then 2% thereafter for the next 5 years after that. So ship operators are taking this seriously because they can't afford to slow down. So the other alternative, they started investing in technologies to be more efficient, right? And it's looking at the amount of carbon you generate. So for instance, you could equip your ship with sails. I used to think that was a joke. We're going to connect, we have a massive container ship, we're going to put sails on it. But no, this is a serious consideration now that can increase your voyaging efficiency for a cost of several $1 million per ship. You can put Flettner rotors, these spinning rotors on to generate electricity. You can add batteries to ships today. You can look at lower carbon fuels. This is the way forward for shipping, but it's just the start, because right after the CII went into force on January 1st, shippers are now facing direct carbon taxation coming out of the EU. It's the first large-scale carbon taxation scheme in the world to be applied to shipping. Ships have paid nitrous oxide taxes in Europe to Norway and the NOx fund for years, but it was never broad scale. Now, in any EU waters, starting later this year, October of this year, ships are going to be buying allowances at least at market prices. Today, that's $75 a ton for an allowance. That's going to cost ships upwards of $11,000 per day in some cases in carbon offsets that they're going to have to purchase. So it is existential, and it's right there at the top for shippers today. They take it very seriously.
Wow. And that's brand new, right? That was signed just at the end of last year.
Shipping was included in the ETS, the exchange traded system, which is the cap and trade system we just talked about, on December 16th. So shippers have had almost no time to prepare. In fact, I was at a conference maybe early fall where ETS came up, and everybody thought the EU was going to do a head fake on this, and like, yeah, psych, we're going to kick it down the road, and they didn't. So now people are scrambling. People are afraid in the industry right now.
Wow. I'm gonna put this back on because this goes through this next video goes through your in-office, some of your in-office equipment and some of your employees.
Sure.
But maybe while we do this, you can explain a little bit around some of the foundational technologies that have evolved just in the past 10 years or so that make this possible. Because a lot of people, when they see any sort of new startup, they say well, why wasn't this existing before? Right? And so maybe you could help shed some light on that.
Let's start with the cost of bandwidth. Right?
Sure.
So the cost of bandwidth have plummeted. We could take a whole history lesson and understand why captains have ultimate authority on board a ship, because there was nobody to talk to when you're at sea with no way of communicating, all the way to Marconi and with the radio and the first real-time reports, real-time being like once and twice a day, noon reports and midnight reports. Today, those are emailed, but today the standard is once a day, ships would broadcast information to their home offices about their position, how much fuel is being consumed, et cetera, provisions on board. But the cost of bandwidth in the past several years has just plummeted. The likes of Starlink are really not even felt just yet in the industry, so they're going to go down even further. But if we tried starting SailPlan 5 years ago, we would have been too early. There was no macro tailwind pushing on this. There was no why do people care? Because they didn't. And it was cost prohibitive to do anything about it. So the historical footing for the industry was to keep all the data on the ship in written records or on computers and email it off as they needed to, typically in batch files. So I think the first big enabling technology for SailPlan is communications at sea. It's not just here, though. It's driving a revolution in digitalization of the fleet. People joke that shipping will never buy software. Well, I think that was true because there was no way of really using software to its potential if there was no way to communicate. But now that we can see cloud applications, penetrating the ocean environment, I think that it's ripe for that type of technology. I think shippers are interested in software just like every other business in the world. I think some of the other enabling technologies here that we look at, on ships, you have to deal with so many different types of standards, right? Serial data. What else? CAN bus, mod bus. You get non-self-describing data sets. So they're data that just flows over that doesn't tell you what they are. You have the more modern, TCP/IP connections to date. You have 4 to 20 milliamp interfaces, which are really analog signals where we have to read the power coming off of the signal. And all of these are locked in different proprietary data standards in many cases with different wrappers over them, making them really just hard to parse out. So one of the first things we did is make this as simple as possible to integrate with. We actually built our own boards, as you can see in that clip, which allow the easy integration of a lot of these different signals. Because on a ship, you never know what you're going to get. We've seen engines that are over 50 years old, which don't have any meaningful data coming off of them. And we've seen ships that were built last year with the most advanced data, networks and high resolution data. And SailPlan's been designed through our boards to ingest all of those, work with all of those engines seamlessly. So that's a little bit about what you're seeing here. I think one of the other innovations that we did, and you can see as we open up the box with the different colors there, those actually line up to, if you splice an Ethernet cable, it makes it really simple for ship operators to install without having to go into the special componentry of SailPlan. Look, you're dealing with a harsh marine environment. It can be raining. It's 100-mile-an-hour winds at sea. You don't want people opening these equipment cabinets up and poking around inside them. It's not good for SailPlan. It's not good for the ship, and it's not good for these components to be exposed. So we've actually built this little compartment that allows ship operators to install this as easily as splicing an Ethernet cable and connecting the colors up. Makes it really easy to work with.
Right. And ships, as I understand, have their own engineers. And so this is built for them to effectively install and maintain themselves.
Correct.
Correct.
That's correct.
And maybe we're seeing Captain Jennifer Norwood, if I'm saying her name correctly. Maybe you could just talk a bit about her and her role at the company.
Captain Jennifer Norwood has a real legacy in the industry. She's incredibly well known. She was one of the first female captains at Maersk. Recently, she was actually honored at Maersk. She was invited over to Europe and featured in a coffee table volume as like some of the pioneers in her industry. Because if you think about what female captains have had to go through historically, it's challenges that probably you and I don't appreciate. And she paved the way for people behind her to do that. Nonetheless, she's a leading voice on autonomy and really the future of mariners. That's how we connected. She was teaching at Maine Maritime Academy, one of our partners today. And I connected with Jennifer and we hit it off instantly. She was interested in shoreside operations and the ability of high-resolution real-time data to actually, help mariners eventually transition ashore. With the future of autonomous technologies, autonomous vessel operations, it's one thing to allow a ship to go out there on its own, but we're always going to have a crew in some form, especially for large ships. But a lot of these positions can move shoreside as long as we have the right data to support them. So SailPlan and Jennifer had a lot to do because under the hood of SailPlan is a high-resolution real-time data platform. Today, it's very focused around towing into the market through emissions and fuel consumption, saving operators money while saving the climate because of reduced air pollution. Yet, that's just a small inkling of the capabilities that we're delivering to these ships. We're going from emissions to diagnostics. We've built real-time high-resolution data feeds, including video. I remember one of our operators said, "What do you need video for? Why do you put?" And so the answer for video, going back to Jennifer Norwood, is to date, some of the engineering students are taught to test whether bearings are failing by touching some of the componentry in there. It's not something that'll show up as a signal on your, the engine heat temperature, because that measures your your coolant temperature. So if a bearing's failing, you have to feel for vibrations and heat coming off certain parts of the engine. That's dangerous, right? Well, how do we know if it's hot? Well, touch it.
Right, touch it with your bare hand.
So we can actually map using thermal cameras the heat signatures coming off of there, and you can have somebody in a shoreside control center wearing, a glove, or just looking at the color scheme and identifying, hey, is that actually failing? Is it overly hot? SailPlan has the ability to provide that to shoreside data to look at that from a safe distance, enabling these crews to start getting off the vessels, working remotely, and that's really what Jennifer's kind of expertise is in shoreside control. So she joined SailPlan a little over a year ago. She came on ahead of our Series A, and we're really glad to have her. She leads our customer success team. So she takes all the hard things about installing SailPlan on a ship the first time we ever did it, to making it into a very simple process that customers can do themselves with some SailPlan help on the side to make sure they're getting it right.
And that kind of ties to a question I had around what is your long-term vision for SailPlan, what it becomes?
It's a great question. If you accept the fact that ESG isn't going anywhere, right? That this has been a slow roll for many years and decades, building a movement towards cleaner environment, more sustainable operations. We see incredible pressure on the shipping industry today. We solve these micro problems by saving operators money. And we also we have macro tailwinds at our back with a direct taxation finally pushing people to adopt these technologies that can be better for all of us. But maritime's just the toe into the water. It's just our initial market. Our technology stack is built for planes, trains, automobiles, mining, ag, airports, terminals, and you name it, everything and above. While we're modeling a combustion engine, we're also monitoring the power. So we're well positioned for the future as we do decarbonize operations, whether it goes to hydrogen, whether it goes to ammonia, whether it goes to fully electrified, operations through batteries. SailPlan's well positioned to go into that future and be the diagnostic and real-time data backbone for the ships, but also for the cars and the other types of transportation modes that are going to rely on these technologies.
Exciting. And I know you're also doing some work with the Coast Guard and the U.S. military. Can you? I know some of it's probably confidential, but maybe you could give us just a little insight as to why they want to work with you.
Yeah. I'll start with the Coast Guard. The Coast Guard's really leaning forward into smart buoy technology. There's almost 50,000 state-owned or federal-owned aids to navigation in the U.S. waterways, and there's probably over 3 million globally. These are fixed assets that tend to be pretty dumb. They're sitting out there and they have a lot to say, but they're not very smart. Let's put it like that. And what I mean by that is that the buoys are put there to tell mariners something. There's a hazard. There's a channel boundary, a place you have to turn. So they're designed to communicate, but today they typically do that either through lights. They're painted, through colors. They're painted red or green or orange or white, or they have buoys or gongs today to communicate audibly. Nonetheless, when sail planning alone, in fact, a total of 0 were smart enabled. So there was no data streaming off these. They only had one way to communicate. And so SailPlan took some of our technology that would be on the bridge of the ship, and we adapted it with some solar panels, and we stuck it on a few of the buoys in the Chesapeake Bay to see whether we could give the buoys a digital presence. And it's worked great. So what it does is allows the buoy to now communicate through data instead of just through analog, paint schemes and sounds. And then it can communicate directly with mariners nearby. It can tell the Coast Guard that it's in the same position that it needs to be in. It hasn't been dragged out of position or struck by a vessel and sunk. You wouldn't believe that that's a problem, but the U.S. Coast Guard spends tens of millions of dollars every year dragging buoys back into the right place because they've been swept out to sea. And then when they're swept out to sea, people are like, where'd it come from?
Where's my buoy? Dude,
right.
Where's my buoy?
Where's my buoy? And if you haven't been on the water, buoys are large. The buoys we're typically on are over 20 feet tall. So you only see a small portion on the surface, but they go way down. So when they break free and they fly around, they cause dangers. They go from something designed to make waterways travel safer into actually the hazard on the water. And so we're picking up great information off the buoys, not only telling the Coast Guard it's in the right spot, but telling the mariners and the pilots on board the ships passing through those channels, whether there's wind gusts coming down in real time, what the water temperature and currents look like. We're actually able to use our passive emissions monitoring to detect the pollution levels throughout the channels. So it's pretty exciting technology for the Coast Guard.
Excellent. I want to get back to you a little bit. You talked about growing up in Florida. You talked a little bit about your grandfather. I mean, how would you kind of classify like the way you grew up and how it impacted you?
I loved growing up in Florida as a kid. In my mind, maybe everybody says this, like there was no better place to grow up. It was open. I remember there was times that I was bored out of my mind, but I think boredom creates, imagination and lets you kind of do things. My grandfather was an entrepreneur. He created a set of nurseries, plant nurseries down in South Florida. He ended up being in the agriculture industry for many years. But I loved it. I go back to my roots, though, with my father on the water. That was my passion. I remember I'm still sort of this way. I just moved back to Florida after 15 years away. And still every day I'm like, can I go to the beach? I have this natural draw towards the water. If I'm not near the water and I don't see water or touch water for some period of time, I get mopey. But being near it is just, it's refreshing. It's kind of... it's part of me. And I think that goes back to being a kid. When I was young, I just want to be around the water, like whatever it was. It doesn't have to be the beach laying out with like getting a tan, but just being physically close to the water and the waterways. One of the first big projects that I did as a kid was around 2000, we helped electrify some of the first water taxis in the United States. They actually were in Fort Lauderdale, and they're still operating today. My father passed away a couple of years ago, and being back, I saw them, the water buses down there, and I saw one of the ones that we first built together, and I was like, that's really cool. And it's like such a so it's like a neat, like I remember standing in that boat and he like shocked himself. I'm like, but nonetheless, it was I think living down there was partly the inspiration for why I wanted to move back and why I wanted to headquarter SailPlan down there.
Do you think Florida gets a bad rap? I mean, the whole Florida man thing and everything.
In some ways, it deserves it.
Okay.
No, I mean there are questionable. Like Florida man is a thing.
Yeah.
Nonetheless, I do think it gets a bad rap.
Mm-hmm.
I think especially I get one of two responses when I move to Florida. I get people cheering me on, like, yes, go DeSantis. And then on the other side of the fence, I get the, oh.
Right.
And it was like, I mean, it's that. It's like a,
right.
oh. Okay.
Right.
Like, and it was like, there's this political thing with Florida. Like, you moved because, and like, I'm going to judge you because you moved down there. And I'm like, I don't know about that. Like, maybe it's just a great place to live.
Yeah.
It has its problems like everywhere.
Right.
I'm not going to say it's roses. What I find is it's incredibly diverse.
Mm-hmm.
I find that having lived in LA, which is also incredibly diverse, in Northern Virginia, it feels diverse there in a good way. I mean, especially with the Caribbean, lots of Latin American influence, people. I love the community that it has as a result of that. People live together. People are happy together. So I do think, in a sense, Florida gets a bad rap because that side of Florida isn't always shown. Mm-hmm. That's the Florida that I have. And I'm sure, with every place, there's two sides of the same coin. So I'm sure there's other pieces of Florida that obviously, Florida man is part of that. But I think Florida gets a bad rap.
Yeah. I was in Miami not too long ago, and I walked into a cafe and tried to order something. They were like, we don't speak English. And I was like, ooh, I kind of like this, actually. Like, I don't, this doesn't happen to me too often.
It doesn't. It's weird that you can live in the United States and go to a place where people just don't speak English.
Yeah.
When I was a kid, so looking at growing up there, I didn't speak any Spanish. I speak just a few words now. I learned French, and I felt like I was like, oh, gosh, everybody speaks Spanish here. I got so annoyed about it. But actually, I think I wasn't in the right headspace. Actually, it's an opportunity to like engage with these other cultures. And then I'm like kicking myself. I'm like, yeah, French is great, but I should have learned Spanish because they bring so much to the community, right? Mm-hmm. So much, especially the Cuban population. Deep entrepreneurship roots, right? So many founders come out of the Cuban community. Look into South Florida, and it's not just the Cubans; it's the Venezuelans, right? I'm seeing someone's going to be like, "Why didn't you mention Brazil? Why didn't you mention Jamaica?" I'm not doing that, but overall, I think it's a huge plus to our community. Even though there's those challenges when you walk into a cafe and you're like, "Okay, no speak English," but
I like it. I like it.
It's okay.
Tell us about some of your early career. You did some work at the Air Force, Thales, and Raytheon. Like, why did you decide to kind of go into that field, and how does that translate to some of the work you're doing, and how you ended up at AirMap? I'd love to hear a little bit more of that story.
Yeah, so when I was growing up, my mom had said, "You have three choices. You can be a doctor, a lawyer, or an accountant." And I said, I don't like any of this. Doctors, I think, do great things, but I think they solve problems on small scales. Like, they solve your problem. Hopefully they do a good job of it. That's great. I love doctors. But so no doctors. On the other hand, accountants count other people's money, and I didn't think that sounded so fun. So I said, this lawyer thing might be a good opportunity to go figure out something. So went to law school in South Florida. I practiced for a day. It was the worst experience of my life. It was awful. It was a very expensive lesson. And nonetheless, I was like, oh, this is a mistake.
Wait a second. I didn't even know this. That's so funny.
I should have seen it coming because in law school, everybody else went out for clerkships. And I became a lifeguard for the summer. And I was like, I can't do this. And everyone's like, are you going to take this seriously? I was like, number one, it's easy. Like you guys are making a big deal about this. Number two, it's wildly boring. But really what it was I felt like the legal industry at the time wasn't, maybe still is, wasn't really solving people's problems. When I worked at the firm, I found that we weren't solving anybody's problems. We were just kind of billing and wasting time, and billing for time seemed awful. I'm like, I want to free up my time, not spend it, on the clock. So I needed a change of scenery and change of pace. I moved out to LA. I went to Pepperdine. I got an MBA. And what I found is that I love the intersectionality of like tech and things, like tech and law, tech and policy, the ability to do things with meaning, which is a big part of my life coming out of, wanting to help the oceans when I was younger. And so out of Pepperdine, I graduated right into the housing crisis. And the Air Force was the only one hiring. I thought, gosh, man, this is like 2 strikes. My life is over. I was like, this is not good. Well, when I did that, I took a job with the Air Force at LA Air Force Base, the Space and Missile Systems Center. And I'm telling you, it was a dream job. It was some of the coolest things in the world. I was working in the Office of Space Launch there. It was then called EELV, Evolved Expendable Launch Vehicles, when Elon Musk came through the office and had sued the office I was working with. And I remember being like, isn't that like the Tesla guy? Like, I hadn't even heard of SpaceX at the time. And they were the laughing stock of the office. Like, everyone's like, oh, what are you going to do? Strap 9 engines onto a rocket and launch it? You're never going to get anywhere. And I remember his point was that back in the day, he said, the Air Force had said, Elon had said to the Air Force, NASA told me I can launch astronauts, and the Air Force told me I can't launch satellites, right? So who has their priorities in the wrong order? People or satellites? And the Air Force said NASA has them in the wrong order, right? Because our satellites are, they cost $20 billion, take 30 years. They're in many cases irreplaceable. So what I did was I helped write the acquisition strategy in that role to help onboard SpaceX and help them start launching rockets for the Air Force. That was a really exciting project. It was like, how do you take this asset, GPS satellite or so on, communications satellite, and give it to a company that is still learning to like build that credibility with you. And so we developed an on-ramp program for them to kind of grow and mature. And as they kind of hit different milestones, just as you might look as like an investor, they got more to go on. And so in the early days, they were allowed to launch like really old, GPS Block 2 satellites. And then they kind of progressed through the as long as they didn't blow anything up or lose them or put them in the wrong orbit, they kind of graduated to the next steps. And I mean, I think they've blown everybody's expectations away. Certainly there. So that was a really exciting start to my career. I fell in love with emerging tech really at that point, and sort of parlayed that forward over the next decade. I left working for the government. I went to work with a great company like Raytheon. I loved working with Raytheon. Great time. At Raytheon, I was working mostly in the Middle East during mostly semi-classified work that we won't overly go into here. But nonetheless, I was around the edges of emerging tech and recently declassified technology that we could sell and work with our Middle East partners on. Eventually coming in to work at Thales and AirMap, and that's where I got involved in the aviation industry. And we're working in a policy role out at Thales and helping open up the airspace for drones. And enabling things like unmanned traffic management, which gives the promise of large-scale drone delivery, and it's an enabling technology for drones. When I went to work with AirMap, Greg McNeil is one of the co-founders of AirMap, super guy, just an amazing person. And he really brought me over to AirMap. I sort of nagged. I'll tell a short story. Greg's a very outspoken person, and I love that about him. He's not afraid to speak his mind. And I remember following him in the drone industry, certainly, and finding the opportunity to get an introduction to him. And like next thing you know, I get to work for him at AirMap, and Spent 2 years working there and before starting SailPlan. And so that was a bit about my career journey. It kind of starting in the space program, eventually moving through drones and back to where I really care about, my heart's in the ocean, my passions for the sea. So kind of it's nice to come full circle, be back in Florida, be back where I'm making an impact in the most important, one of the most important environments in my mind.
Yeah. Well, so first off, shout out to Greg. He's been on this podcast.
Has he?
Yeah, yeah. By the way, in one of our first or second years, he's a longtime friend of mine. He introduced us.
Yep.
So shout out to, and he's your co-founder and chairman,
Yes.
co-founding chairman of SailPlan. And but it is interesting how your careers come full circle, and the skills and experiences you've come along the way are have sort of made you uniquely capable to start this company around policy, technology, security, like how all these things fit together. It's I love these stories because it's like you can't map it out on paper in terms of like, okay, this is how I'm going to architect my career. Like you said, Air Force was the only one who was hiring.
Yeah.
Then all of a sudden you're meeting and interacting with Elon Musk and SpaceX. Like you can't plan these things.
You can't. And there's this. I listen to country music. There's this old song, "God Bless the Broken Road," that led me straight to you. And I really do pinch myself. I'm so lucky to look back and I can see this path. And I'm like, somebody had a plan. Because I'm in exactly the right spot at the right time with the right skill set and the right background to go be able to solve this problem. And it really is a greenfield, we call it blue water problem. When we started creating SailPlan, people were like, this isn't a problem. I'm like, no, it is. They're like, how do you know how to work with it? Like, well, by chance, I happened to build boats as a kid. And turns, so it's really an apt broken road story here. That's true.
All right, I want to turn to your personal philosophy here. This is a new question, so I'm going to caveat it that this is a weird one.
Okay.
Okay, but I'm going to give it a shot. Okay, so if you think about the long arc of history,
yeah.
Okay, each of us humans are effectively like an insignificant, like little data point, right?
Are we?
Well, hear my argument, right, and then react to it. Even U.S. presidents, right? Like, I don't know if you could name the 12th U.S. president, but it's Zachary Taylor.
Okay.
Okay. War hero, in his time, the most important person in the country, if not one in the world, right?
Okay.
But most people on the street, you ask them who's Zachary Taylor, they have no idea, right? So, in the long arc of history, millions and millions of years, in a sense, like all of us will be, forgotten or lost to history. So knowing that, and having one life to live, like, how do you think about, finding meaning in your life and like the impact that you could have?
So I like that. You put me on my back foot, and your premise is you're not very meaningful because over time, even if you were the president of the United States, much less the 12th president, no one's going to remember you. But how do you see yourself making an impact? Now, I like that. That was good framing. I am perpetually optimistic. Let's go back to that. So what drives me is really the core of that question in my mind. And for me, I'm optimistic that we can make changes in our lifetime and for that of my children and your children and their children's children. Then if we're just myopically focused on the impact that we can make today and here or in our life cycle, then we're going to miss the big picture changes, right? And so why I tie that back to this question is because what I believe is that some of the changes we're making today in society, in the world, in the climate space are going to have these ripple effects. Right? We're to go back to ships, we're steering the ship just a little bit today so that we can make an impact. I actually don't believe it's for our generation. I think it's for the next generations to come. And if we don't take these hard steps today, what's it going to be like 100 years from now? And so if you're looking at impact, and what drives me, one is I'm optimistic that we're doing the right things today. It may feel like we're not going fast enough, but I think we don't need to go much faster. We're taking the right steps. And two, I think the impact is going to be felt by generations past us who said, well, they bit the bullet. They made some hard decisions there. That was a rough period in the world, 2022, 2020, 2021, 2022, and probably the next decade is going to be really rough. And I think that's how we have to review. Like, that's the lens that I see impact through. It's not just us. It's multi-generational.
Yeah, and the shipping metaphor is apt, right? Because even a tiny tweak might not look like anything now, but in the long term, that could be hundreds, thousands of miles of a difference.
That's exactly right.
Is there a quote that you think about sometimes in times of struggle or frustration? Or
there are many. The simplest quote is gosh, what's that actor's name? And I forgot his name right now. Anyways, it will be okay. It will be okay. Sometimes like as a founder, or maybe you're founding a fund, so you probably go through the same thing. But at least on my side, there's the pucker factor, followed by the relief, followed by another pucker factor, and it's up and down, and sometimes you get kicked down, and then you get lifted up and pulled sideways, all in a day. And so sometimes I just have to step back and say, like, it'll be okay. And that's one of the big guiding quotes I think of, is, and it's not that magnanimous, but it's calming, and it's reassuring that there's a signal and there's noise. And if you look back to that broken road that got us here in the first place, it's all worked out, and it will be okay.
My grandma used to say, it'll all come out in the wash.
Yeah.
And it's like, just like that little simple phrase, like, it's the same kind of thing. It's, it can be powerful. This is my pet favorite question. What's your most contrarian opinion?
That Florida is a great place to live.
You've already made that case pretty well.
Yeah. I think fair enough. It's fairly contrarian these days to like Florida.
That is pretty contrarian.
It is, especially here in California. Yes. It's like I was gonna wear my Florida hat on the plane and get kicked off. But I think that's probably an apt contrarian opinion these days. I think other things are. If we look in the climate space directly, I'll tackle that for a minute. I think it would be contrarian to say that I don't think oil and gas is going anywhere for the next 100 years. I know it's maybe not what we like to hear, but if you look at the facts, oil has done really good things for the world. You might get your podcast banned that I said that now. Look, pre-oil, we were killing whales to burn their fat in candles, right? We needed oil, so we had to get it from non-petroleum based sources in the ground. So really, when the oil and gas industry started, it ended the whaling industry, and so we forget that, and that was like a silver lining. I think that we needed oil to come on, and we need to get off of it, but I think that we misunderstand just how hard and how fundamental oil and gas is to the operation of the world. It doesn't just power transportation. It's in medical devices. It's in our food, right? It's in everything we do. So what I think is maybe a smarter answer is try to decarbonize and remove oil as quickly as possible from the transportation side, and be really smart about what's replacing it, because simply replacing it or simply shifting Scope 1 emissions that are burning oil to Scope 2, which are burning oil, may look like we did a whole lot, but maybe we didn't, and maybe we did something worse. So I think the smarter answer there, and maybe the contrarian answer, is do that really fast, but make sure that we have enough oil around for those applications that absolutely need oil in the future. And it is a non-recurring natural resource. We've got to remember it's a resource. It's not a curse on the world that we have oil. We do need it for things. So I think those are some of the key things there that maybe are contrarian these days to say.
Can you describe what you mean by scope 1 and 2 and maybe 3 emissions?
Yeah.
People may not know what that means.
I would argue that the definitions are still fairly fuzzy.
Okay.
I don't think the world has fully settled on especially what scope 3 are. But let's start with scope 1 emissions are the emissions that I generate in my line of business. If I'm operating a vessel in our world and I'm burning fuel, I'm emitting emissions from the burning of that fuel. I'm also doing a bunch of other activities in my business as well. Those all generate emissions. Those are all scope 1. They're primarily generated by me. So if you think about this in the context of a consumer or their car, they turn on their car that's burning fossil fuels, it's generating emissions right there on the spot. That's a scope 1 emission for the person. Removing that to scope 2 is emissions generated from support activities, right? You're not the primary source of the emitter. You're now getting those emissions from a secondary source. So now when you electrify your car, you're not generating the emission directly. You're letting somebody else do this, but you're contracting for those emissions, right? So now a power plant is generating those emissions. Those become scope 2 emissions to you. Scope 3 are really hard to understand, and some argument around what they are. My take on them, which is probably going to be argued by 25 other people, is that they're emissions that occur from your supply chain. Right? So I have a water bottle, and the emissions that were created as part of the water bottle that became part of are in my supplier network because I bought the water bottle. Well, those are scope 3 emissions there. It's a hard to understand concept, but it tries to help you optimize your own supply chain footprint. That's a good
overview though for people. And coming back to your earlier point, I've been in building and investing in climate tech long enough where I agree in that the transition away from oil and gas is going to take a long time, and it should. Obviously, the quicker the better, but a lot of people don't realize that the whole plastics industry, right? All polymers really come from petroleum-based inputs, and also they're finding kind of more. There's more coming out in terms of some of the supply chain around electric vehicles and cobalt in the Congo and things like that. So obviously faster is better, but it has to be done in a responsible way.
Correct. You're wearing a Patagonia jacket, and one of the interesting things that reminds me of Patagonia, not to hang out them to dry in this instance, but I remember 10 years ago they developed a sweater made of bottles. Remember this, and it said this jacket is made of recycled plastic bottles. And I'm like, that's awesome. I want one. This is incredible. But as you look into what happens, and it's not just Patagonia that did this, but we've incorporated plastics into our clothing. And then through the wash cycle, these plastics are degrading, right? And so now we're getting microplastics into the water and into our bloodstream as a result of ingesting them. They're going into our food supply. You can find them in fish. And so I think that's one of the examples here that I don't want to see happen with oil and gas. Like, we have a great step forward. Somebody figures out how to take plastic bottles and create a sweater out of them, and everyone's like, "This is great." And then you find out that there's a lot of downside risk because that sweater then breaks down into these microplastics, which are unmanageable. And now we have trillions of these particles floating around our waters and breathing them in some cases. So how do we avoid that problem as we look to decarbonize? That's what keeps me up at night in many ways. It's not that we can't decarbonize. It's doing it smart and sustainably ensuring that, a certain special interest or that's, this certain special interest or that special interest don't push us in the direction that we just decarbonize so fast that we put ourselves in another problem. You pointed out nickel and cobalt and the mining, and you can then even get into like slavery and challenges there. So we want to be really smart about how we do this. And I think making sure we hear all voices at the table, making sure we consider strategies, making sure we're thinking about second order and tertiary effects to what decarbonization means. I'll give you a real example there. Ammonia. Ammonia sounds great as a potential future fuel for ships, but if it leaks out, it'll kill the crew. So, and it's highly toxic. So ammonia then it's only interesting if it can be made green. So then, well, how do you make green ammonia? Well, you need a green emission source to begin with, or you can get it from an algae. So you got to look into what the risks of our transition might be, and I think manage that appropriately.
Right. I think the headline here is that there's complexity here that needs to be understood, and that's why I get nervous sometimes when I see new people who want to get into climate tech, and they're so idealistic that they just kind of gloss over some of these complexities. You talked a little bit earlier about having an impact now that's going to affect future generations. And big part of what we do here is kind of, helping people who are, younger, earlier in their career and whatnot. What advice would you give to a young person, maybe they're passionate about climate, trying to figure out how to make an impact with their life? Like, what kind of advice, would you wish you had heard when you were younger, and the kinds of advice you give to young folks early in their career?
I'd say do something that matters, not necessarily that you love. I find that if you do something you love, you might end up considering what you love work and then not loving it so much anymore. And I don't know that that's the best advice, but doing something that matters, that has an impact. Climate is one of many things that matter. It's not the only thing that matters. So there's lots of ways to make an impact. Kind of find your guiding light there, and try. Like, you're young, go try. It's easier than ever to go try. If you, especially in climate. So I think you sort of just touched on that. There's this idealistic approach to climate, and then there's a very practical approach to climate. Figure out kind of what side of the coin you approach it with. If you're looking to try, feel like you can step out into something more practical, as opposed to more idealistic, which may open up more opportunities for you also to drive change in a meaningful way. So I guess, under the hood there, that's be open, be experimental, go try, find something that matters, but not necessarily something you love, and experiment. I guess it's sort of how you found startup too, right? Be willing to try and fail and see what works, and have a North Star that you're after, but don't be hooked on the one way to get there.
Great advice. Jacob, this has been a pleasure. If there are folks who are watching here and they want to get in touch with you, follow you, follow what's happening with SailPlan, what's the best way for them to do that?
SailPlan.com. Follow us on LinkedIn. We are pretty active on LinkedIn. And if anyone wants to get in touch, send me an email, jacob@sailplan.com. I'd love to hear from you. Love to talk.
Excellent. Jacob, thank you so much for being here. You've wildly exceeded my expectations for this podcast.
Well, you must have had low expectations. Thanks, Joe.
Thanks again, man.
All right.
All right.